Hey guys! So in this video I want to translate a lot of the theoretical stuff we've been doing and the mathematical stuff into actual hardware measurement and how quantum computers physically work. So we've talked about state vectors and how a ket psi can be represented by alpha of ket 0 plus beta of ket 1. And those alpha and beta coefficients give us information about the probabilities of getting either ket 0 or ket 1. And the way to figure out those probabilities is by squaring either alpha or beta. Squaring alpha gives us the probability of getting ket 0, and squaring beta gives us the probability of getting ket 1. Now, when we actually go in and measure the system, we only get classical information. So it's very hard to tell what that alpha and that beta eventually is. So what we do, because the wave function collapses in that case. It's terminology from some previous videos. But it essentially goes from a superposition where there's probabilities of getting ket 0 and ket 1 to only one piece of information. Either we have ket 0 or we have ket 1. Now, the way quantum computers actually solve this problem is by doing that same measurement over and over and over and over again, going from one measurement to maybe 1,000 measurements or 10,000 measurements. So we get a probability distribution of the ket 0s and the ket 1s. And based on that probability distribution, we can go back and see what the probabilities of getting ket 0 and ket 1 are. And then we can go back and find what alpha and beta are, just by taking the square root of those values. So that's a very simple way of that quantum computers solve this problem of how do we know what alpha and beta is if we can't directly measure it. And building on what we talked about before, that alpha and that beta represent the amplitudes of the wave function. But squaring them gives you the probabilities. So yeah, that's how quantum hardware actually measures those probabilities. Bye guys.